and welcome to the channel. So we've got this Sound City 120 head, and we looked at this, we did an assessment video on it a while ago, and we're going to get this amp recapped. So if we just have a look, we've got the capacitors here, so we're going to get those in there. We've also got pink. So we've got capacitor here, here. I think these two are 220 microfarad, and we've got, I think, a couple of 50s there. They might be 32. They're 32s. There's a couple of 32s there. So we're going to go through this amp and recap it. We've got capacitors here, here, here. We've got a couple there. Got one here. The mustard caps should all be good in this. It's very rare that those leak. And then we've got a bypass cap there. We'll check all the resistors, go through it, and then it should be ready to fire up. Not a massive job, pretty big but not massive. And we need to do something with this power cable as well, because this is quite frankly shocking. But that's what they did in those days. Right, I'll crack on and we'll start getting these capacitors out. So we've got these first capacitors in there. A bit fiddly with all these components going over like this, and obviously I've had to do some things to make it a little more safe. So if we look, I've got heat shrink over there because that's got a potential to be pushed down onto there, onto this live on this capacitor here, and there's also potential there. Out of tolerance 22k resistor, so that's been changed. We've got the balancing resistors on. Now the caps that came out of this were 200 microfarad each, and I'm sure at the beginning of the video when you saw me with the 100 microfarad caps wondering why I was putting those in. Well, these are 100 plus 100. So what we have done here, we have paralleled each of these capacitors, which will give us double, which does make those 200. And if we attach on there, and I attach on here where there's ground, and now if we look, you can see we've got 100 microfarad, because the two 200s were in series, giving us 100 microfarad originally. But because we've paralleled these to 200, we've now got we're back to 100 microfarad. So that's how we've done that. So they are all done now. At these other capacitors here, we've got the schematic here. So if we look on this schematic, and it's not the best way it's been drawn out, but you can see we're coming off here from the rectifier, the bridge, and then we've got these two in series here, which is 200 plus 200, which makes 100. And as I say, I've explained how we've just done those other caps. Then it comes along here, goes through the 100 ohms, sorry, goes through the standby switch, then the 100 ohms, and then that goes for the screens. And this here, this is the smoothing for the screens. And if you look, that's 32 in series. That's only 16 microfarad. Then we've got the 6.8k, and there's another 32 there, because this is ground, negative. There, look, this is ground. So that then goes off and smooths the phase inverter. So unless my eyes are deceiving me, we've got more smoothing on the phase inverter than we have on the screens. Right, so let's have a look where we are. We've got Captain Bleeper here. So if we look of this screen resistor that was fitted, you can see that there's no shrink tubing on that, and if we push that down, it sits very nicely onto the grid of that output tube, and the results of that are goodbye EL34 if the screen voltage is applied to the grid. That is very sloppy to leave that like that. That could easily get pushed down onto there. Look at the distance between there, it's not much more than the thickness of this. So yeah, not good that one, but we'll sort that out. So let's trace this through then, because they are, if you're working on these, they're, you know, a lot of people have said that, you know, these are tricky amps to work on. Let's just lose that bulb because we're flickering. There we go. So we'll make it a bit clearer now than the first time. So we've got coming out of here, and we're coming along here like so. That's node 1. We're coming through the standby switch, 100 ohm resistor. So if we look on here, we've got the diodes here. So this orange wire here is presenting the full voltage. Not found where the center tap's connected yet either. On here. So the center tap is connected here. That's the center tap. Miles away from all of this scenario here. So let's check here, and there we go. So somewhere along this line here, that must be connected, and I can't quite see it for the minute, but anyway, that is center tap over there. See what I mean about the bizarre wiring of these things? And center tap is there. This is the 100 ohm resistor here, and if we go to the smoothing here, and we just go up to here, you can see now we've got continuity there. So that is the screen capacitor. That goes through this negative here because it's in series. It goes down here to this positive, and then goes to the negative there. There's the balancing resistor, 220k, and the other balancing resistor is here. So that's where we are with that. So if we look at that on here, there's the 100 ohm resistor. It's come through the standby switch, and you can see standby center tap there on the output transformer is connected there. So there's a very long wire going all the way up there from the point that I showed you where center tap was coming in from the transformer. Here we've only got 32 in series, so we'll lose that. I don't want that anyway. That's garbage. So we got rid of that, and we'll snip here, and we'll snip here. I'll probably change that bit of wire anyway, it's no big deal. And then we'll snip along here like so and pull him out, because I've loosened the bolts on all of them. That looks a mess, doesn't it? It's all bulgy and crimply. But I'm modifying this power supply slightly, and there's a very good reason for it, and all will be revealed at the end of this video. You know what I'm like, and you know what this channel's like. We're always trying to do something a bit different. So what I'm going to do here is I'm going to put this 50 microfarad in at 500 volts working. Now, I checked on this schematic, the AC volts coming in on the secondary is 350 volts. So if I times that by 1.414 gives me 494 volts, which is under 500 volts. Now that'll only be when this amp's switched on and it's cold. And I did do this once before, and somebody left a comment saying, why have you put the capacitor so close to its tolerance and not put them in series? Well, how many amps do you look inside where you see 480, 90 volts when you first switch it on, which will go all the way through the capacitors, and then you'll see that they've only got 450 volt capacitors on the nodes 2, on nodes 3, 4, you know, whatever, for the preamp stage, the smoothing for the preamp. So they're already 50 microfarad under. I see that loads of times, but they're only under until the tubes start conducting, and then as the amp begins to draw current, the resistors then drop the voltage in the circuit. That's not even over, that's 6 volts under for 20 seconds. So I'm going to put that in, and there's another reason why I'm going to put that in. That's 50 microfarads on the screens, which is really what we should have. And then we'll just have 50 microfarad for the next node. As I said, there is a reason that I'm altering this power supply, and all will be revealed at the end of the video. So I've been looking at some more options for the channel, so I'm going to offer this out now. How would some of you feel about a channel membership? Is there any interest in that? And what I was thinking of doing on the channel membership, some of these videos get quite long, so what I've thought about doing is doing more edited versions of this just to put up normally, and then the members videos of this same amp will have there'll just be more in it, just, you know, going through things a lot more, seeing things fitted, whatever. So let me know in the comments to see how you all feel about channel membership and who would be interested in that. Anyway, enough waffling, let's get these caps fitted. Right, so if you're doing this on one of these sound cities and you're putting this one cap in, here's the feed for the screens, and there's the two 20k resistor here that was the balancing resistor for the single cap that was on there, so we obviously don't need that, so he needs to go. So you need to remove him, he needs to go, and then I've turned this straight round now because it was diagonal before, you can see, so we need to remake, just shorten this, get that through the holes. The grounds are there, this won't reach, so we need a new one, but you now need to connect that onto this one. Yes, you need to connect it onto that one there. The other thing as well is you need to connect this, disconnect this wire here. This is the wire that went to the capacitor, the live for the capacitor we snipped off, so that needs to go. Right, so done quite a bit more. So we've got the power cable in, and we've soldered the ground on there, so a bit of slack on him. What else have we done? So change this resistor, this 6.8 to 1k, and again that's what will be revealed at the end of the video. Change that 22k there, that was out of tolerance. Change this resistor, I think that's on the negative feedback. Yeah, it is, just remember it is, yeah, 22k, that was out of tolerance. We've got a new 10k resistor on this capacitor here, drop-in resistor, metal oxide. Now then, the bias cap. So the bias cap was grounded here, and that's just no good. They do that on these sound cities. If that nut comes loose and drops off, the bias will just disconnect. It needs a proper connection to ground, not through this wafer tag strip. So what I've done is I've utilised a hole that was here, and I've put a proper ground lug in, soldered it into the ground lug, and then it's soldered back to where it was. Instead of going across there, we put that radial in there. He stands up quite nice. There's some damage on this back as well. If I just drop this socket out here, that you might not be able to see on the camera well, but that hole, that's been pushed right in there with that hole, so that's a bit of a problem. And this is quite a thick steel chassis, so there'll be no getting that out easily. Pink's dinner still here. He's coming and having a nibble. Henchman Dreg's knocking the camera. That's my dog Shaft, but he's on guard duty, so he's known as Henchman Dregs. So yeah, we've got the 50 microfarad in, got the 32 microfarad in, the can caps there. Now, I've taken the grounds off the cathodes on the tubes, and I'm going to put some 1% 1 ohm resistors on here. Because there's such a lot of tubes in this amp, it's just easy to bias it and safer with the amount of voltage that's going on in here. Although I don't mind using Ohm's law to do it, but it's simpler just to use the if long as those resistors are accurate. You need 1% resistors if you're going to do this, but they just go, you just put the resistor to ground. Now that brings me back to cathode and ground. This obviously is a restore, and obviously it's not going to be plugged in till it's finished. But if you're biasing one of these and you decide that you're going to put those resistors on, the one thing you must do before you even make a start is take the plug out. Because if you get between cathode and ground, you will you'll get a new hairstyle, and it won't be pleasant. That is one of the most dangerous things. If you're working between cathode and ground, make sure that the amp is unplugged and the caps are drained. Getting a belt off something is one thing, but getting between that, you just become a current meter. That's the last thing you want to do. Anyway, enough waffling. So let's get those resistors and have a nosy at them. Here we go. So these are 1 ohm resistors, 1%, and I'll test these not on these meters, but I'm going to test these on I've got a more sophisticated tester, and get a much more accurate reading on low ohms, low resistance components like this. So we're going to put these in. Now there's a few things that I've left in here. I've left this cap in, I've left these caps in. I've still got the diodes to change, but I'm not going to change these caps just yet, and they're not detriment to firing it up or anything like that. So I'm just going to leave those for the time being, and as I said, I shall reveal all at the end of the video. Right, so we've got the 1 ohm resistors in there, and I've changed the diodes on the power supply there, the bridge rectifier, they're all changed. So we're going to fire this amp up now, just see where we are with it. Again, I've done nothing to the preamp, it's just the power amp section that we've sorted out. I'm going to start with a 40 watt bulb, and off we go with that. That's quite bright, but it will be, but it's getting dimmer, so that's a good sign. And if we go up there, you can see we've got 170 80 volts, and that's climbing slowly. We've got 100 volts climbing and 110 milliamps. That's on the wall. Bulb's getting dimmer now, so that's good news. We have got the signal generator through it, so we'll see if we get any sound. 230 now, you see that's coming down, so we are getting some conductance, and we've got 115 volts going in, and look at that, there we go, we've got sound already. Got quite a fair old hum on that. Yes, and that's on the 0.72 millivolts, but we won't have much yet. We've not got that much power going through it. So 1 millivolt will be 10 milliamps, so we've got 0.7 of a milliamp according to that. go a bit further. That's a 60-watt bulb, and you can see that's now got quite a bit more volume, lurking for a spot of dinner. These cables are causing a bit of interference. So 2.68 millivolts. So that is about 26 milliamps. Let's just take that out. Quite noisy, isn't it, on that EQ? So this looks like there's a problem on there, unless it's a preamp tube, but that's not clever, but never mind. So we've got 265 volts now going into the amp. So let's just see what that is. Plate to ground. We'll have to take it off millivolts, won't we? It'll be no good on there, it's no good on AC either. There we go. Because although we're monitoring that voltage, that's not from the plate, that's from the first node. 264, actually, actual fact, that's exactly the same. 264.5 on both meters. So yeah, that's so that's pretty good. 7 watts they're doing. Well, that one is. I don't know about the other one. Remember, we've only got 2 tubes in it. So let's check the other side. 7.1 millivolts. 2.86 millivolts. I think that tube's tainted. Now, one of those tubes, if you remember, one of those tubes, that's 70 milliamps. 18 watts already. So that tube's had it, and there is a bit of a whiff coming from that. One of those tubes had red plated, if you remember. Probably don't remember from the last video. So I think what we'll do now, we'll shut down, we'll wait for that tube to cool down, and we'll remove it. Now, if I put another tube in there and it's high, then we need to be looking at the coupling caps. Although the bias, I suppose, could be wound up on it. Let's check the bias. Fine with that tube, it's only at 18 watts. It's not causing any massive issues. It will be when we take it off the bulb, mind you. It'll just go up. But the bulbs will hold it in place. Or the bulb at the minute, because we've only got one in at the minute. Let's just check what bias we've got. Or let's check we've got bias on both sides. And again, the bulb will happily bias the amp. Let's see what we've got on. We need to put it back onto DC volts. There. -24. That's healthy. This amp has got 2 individual bias pots, so, and the next one there, 23.8. So roughly the same bias there. And a massive difference in those tubes. So it looks like one of those tubes is kaput. That's as cold as it'll go. What about this one? So is that. Right, let's just do some voltage checks then. So let's see what's on the screen. 266 on the screen. And the plate, 267. What we got on this one? Same. So 142 volts going, 143 volts going in. We've got 267 plate volts, but we've got a massive offset on those tubes, and that's the second tube I've put in there. Right, what we'll do this time is swap the tubes round. Right, let's check again then. We've got it running. So this tube was 2 point whatever million. There we go, look, 7. And the other side is 2. So 2 of those tubes are drawing much higher current, way more current. Now, given the fact that I've only got 268 volts on this amp and a 60 watt bulb, so let's get that out before it gets too hot. Now, that's one of the Mullard tubes. We'll pop him over there. Let's try this one. I think I've got the first one mixed up now. We can't really proceed with 70 milliamps being drawn at 143 volts. So something's not right there. Well, I've got 5 millivolts there, and that's up to 2. So it looks like we've got some pretty potent tubes, and one that's a bit limp, which is that one. So he's a bit limp, and he has red plated at some time. So I wonder if he's had his loins wrenched and he's no longer any good. Right, we've got all 6 in now, and the bulb, sorry, we just had to focus there, and by gum, the bulb's got bright with the extra filament voltage. And now we're drawing 250 milliamps. Let's see what we've got on this tube. 2 millivolts ish. We're only looking for ish at the minute, we're not going. 4, nearly 5 millivolts, so that one's doing 50 milliamps. That one's doing 76 milliamps. That one's doing 25 milliamps. And that one's doing 90 milliamps. Wow. So yes, these tubes are a bit sick, according to that. So I tell you what I think's wrong with this amp. There's not enough bias volts on it. And that is a common problem with these amps. They just lack bias volts. They just don't generate enough. Negative 25, and we've got 152 going in there. And I ain't prepared to push that anymore. We need more bias volts, I'm afraid. So the problem here is that we've got some tubes that are high current drawing and some that are low current drawing. And obviously when this amp was made, they obviously selected very low current drawing tubes for it many years ago. In the meantime, various things have got shoved into it. Most people don't understand that that some amps require lower current tubes, such as the boogies. So this is a temperamental old thing. And now all the controls are down and it is getting quite noisy now. We've got 153.8 volts going into it off the wall, and it's drawing 333 milliamps, which is not excessive, is it? But one of those tubes is running at 26 watts, which will be okay while it's idling. Nothing's being played through it. It has gone over, but we're on the bulb. So right, so drawing 330 milliamps off the wall. We've got some tubes that obviously we take it off the current limiter, they'll just red plate immediately because they simply don't have enough bias voltage. Now there is another way of cooling this amp down slightly, and that is to increase this screen resistor here between nodes 1 and that's node 2 there. Increase that screen resistor. Now I've just measured across that, there's 0.98 of a volt going across it, which obviously is nothing. But as we increase that, we'll need a good sized resistor. But the more volts we knock off the screens, the cooler this amp will run. So biasing an amp is also balanced between negative volts on the grid and the screen voltage. So our 100 ohm resistor is there, and that feeds the screens there. So we could change that, but it would need to be quite a change, something along the regions of 1k. Now I've got a 300 ohm 10 watt ohmite resistor here, 300 ohms. You can see him there. So what we're going to do, and this is dangerous if you don't know what you're doing, so jumpering resistors in with this voltage is not advisable unless you have a current limiter, which is what we have. So but I thought we'd go through this just so, I have done this before on the channel, but I thought we'd go through this just to show people how this works. So when you're changing these resistors, obviously we're looking to reduce the bias, but we also need the correct size resistor. Now if we measure across there and there, we've now got half a volt, so it probably isn't going to make that much difference with that 200 ohm change. We'll probably find that the voltage doesn't alter a great deal, the current rather doesn't alter a great deal. Let's just check that again. Sorry, 2.76. So now it's dropping 2.76 now. So no issues yet, but what we need to always make sure is that the resistor is going to do the job. So 2.76 times 2.76, which is squared obviously, and then if we divide that by 300, that's a quarter of a watt, which is still well within the tolerance of the resistor. Now that will go up as we increase the ohmage, and we're hoping that the amp will get to start to run a bit cooler. We're now drawing 320 milliamps instead of 330 milliamps. Can't seem to get a reading off that resistor, I don't know why. It's most odd. None of the meters will. Very strange. Let's go on to the next one. 4.7. 6.6, so that's come down because that was about 7 point something millivolts. Let's see what Mr. Greedy on the end's doing. Although he isn't one of the original tubes in the amp, it's one I put in for the one that's got no locator. He's now down to 780 milliamps from 900, so already the current's beginning to come down on the tubes already. Now we'll still have the same negative volts. I don't know what else I've got at that size. Let me have a route round. So we've now got a 560 ohm resistor in there, and the volts drop now. Is 4.7 volts. Not gone up much. Well, let's do the maths. .394 watts now, so near enough 0.4 of a watt. So now let's also look at what's on the plates and what's on the screens. So if we go onto this tube, we've got 292, 287. So you can see now there's only a volts difference before, it's now 5 volts difference, which is what's across that resistor, more or less. Right, let's have a look at Mr. Greedy now in the and see what he's drawing. Let's pop that in there. and now he's down to 780 milliamps, which is about what he was before, I think. Right, now I've got a 3.3k resistor in there now, and we've got 309 on the plate and 282 on the screen. So now let's see what Mr. Greedy is demanding in current. Let's see, shall we? Now it's only 520 millivolts. I keep saying milliamps, it's millivolts, and that's 52 milliamps. I keep saying milliamps, millivolts. So that's now down to 52 millivolts from 980, was it? Something like that. 900 anyway. So 90, in other words, it's gone to 52 milliamps from 90 milliamps. So by lowering the screen voltage, you can lower the bias on the tubes. So let's go through. You can't, for some reason, can't get a reading off of this one. And I know those resistors were good because I tested them on the LCR meter with the Kelvin leads. But that one doesn't want, it has shown a reading occasionally. And I think I may have spotted it. I think I put that resistor through there and I forgot to clip the waste off, and it's resting on the bolt, so it's cancelling out the resistor. Not an issue safety or anything like that, it's just cancelling out the resistor. The resistor's only 1 ohms. I just spotted that now with it being right in the corner there. Didn't actually see that, so I just need a pair of pliers and I think we'll be on his way with that. So basically it's just like jumpering out the resistor. I can see that on there now. There we go. Let's just pull the plug, just ferreting in here. Ah yes, I can see that now. There we go. Now it should work. We'll get the hoover in there and get that out. It's actually there, but we'll get it out later. We know where it is. It's under test conditions, so it's not a problem. So that's working. So that's all that was. Just left just the waste end on the resistor there. It was just touching that bolt, so it was just jumping out the resistor. It was going straight to ground. Still on 140 watts of bulbs. Now drawing 320 milliamps. Still only got 330 volts going into the amp, and that's coming down now because the tubes are drawing more current. The preamp tubes will be as well. So that one's 37 milliamps. What a load of tosh. So 37 milliamps, 23, 64, 23, so those two are a match. Those two are close, but I won't call that a particularly brilliant match. And those two are nowhere near. So yeah, basically that's just a load of tosh. We can find only 2 of them that are matched out of those 6. Bearing in mind one of them is what I've put in there because of the locator missing on this one. Now we've reached the end of the video because obviously this video has been going on a while, and I need to reveal all. So what I'm going to do with this amp, and the reason I haven't changed any of the caps on the preamp section, is because I'm going to convert this into a high watt DR103, and there's a lot of similarities in this circuit. One of the problems with these amps that people always say, and they have got the old famous nickname, Sound City, Sound Yeah, is this active tone circuit going on? It's dreadful. So we're going to convert this preamp. We're going to turn this amp into a high watt, and it's not that difficult to do. A lot of this stuff's already in place. The power supply now we've got more or less in place, which is why I was altering just a few things in the power supply. In the next video on this amp, we will be having a look at the schematics side by side and seeing what we need to change in this amp. The end result of this, we should have an excellent sounding amplifier. Whatever happens with this amp, we need to get rid of that active tone stack because they just don't sound very good. And nobody's really, to my knowledge, gone mad modding these. So I'm afraid that's been a strange video, really. I was expecting higher hopes. And it's not particularly good news for the customer either that owns this, because it looks like he's going to have to fork for a new set of tubes. There's just no way around it. So that'll do it for this one. So thanks for watching, and you all take care, and I'll see you all in the next one. Bye bye for now.